Hello, Legacy Sabers. So this is for the semester 1 review for Unit 7 Polynomial Functions. First question we're going to go over is 24x cubed minus 28x squared plus 8x equals 0. So we need to factor and solve. So first thing I notice about all of these numbers, they all have a 4. And they all have an x. So let's do a GCF of 4x. So I'm going to say 4x, and I'm going to factor that out. So I get 6x squared minus 7x plus 2 equals 0. Now, I need to factor all the way. So I'm going to factor 6x squared minus 7x plus 2. So I'm going to do two parenthesis sets. Oh, things that make 6x squared. 6x and 1x. 3x and 1x. Let's try a 3x and a 2x. And then things that make 2 would be a 2 and a 1. I probably want the 2 to multiply by the 2 and the 1 by the 3, because then I would get a 3x and a 4x, which would make me a negative 7 if they're both negative. Now, don't forget, you do have to set equal to 0. So 4x equals 0. I would get x equals 0. 3x minus 2 equals 0. I would get x is 2/3. And then for 2x minus 1 equals 0, I would get x equals 1/2 for my 3 answers there. Number 32, again, another factoring problem. No GCF this time. I just got to set up my factoring right away. Just notice we're not equal to 0. That's just sad, isn't it? So let's make ourselves equal to 0. Two things that make an x to the 4th would be an x squared and an x squared. Sorry, guys. There we go. And then things that multiplied give us 4. Let's do a 4 and a 1. Both of those being negative would give me a negative 5x squared if I multiplied out. But I did notice x squared minus 4, that factors again. Because remember when we did factoring polynomials, the question we always ask ourselves is, can I factor again? X squared minus 1, that factors again as well into x minus 1, x plus 1. Difference of perfect squares right there. So if I set all of that equal to 0, I will get x equals negative 2, x equals 2, x equals negative 1, and x equals 1. 4 answers. Remember, your answers do have to equal... Be gone. There you go. Your answers do have to equal the number of your exponent, your highest exponent. Now I got to divide. This one, since it is an x plus 1, I'm going to do synthetic division. You can do synthetic when it's just 1x plus 1. You cannot do it when it is something in front of the x, so like 3x plus 2. Can't do that one in synthetic. We have to do that one long division. So first thing I'm going to do is I'm going to set up the inside of my synthetic. So it's going to be x cubed, x squared, x, and then a no x. And then I have a 2, a 5, a negative 7, and a negative 6, because those are the stuff that's corresponding. Now remember, the stuff that's on the outside, you're going to set x plus 1 equal to 0, and you're going to get x equals negative 1. So negative 1 is what's going to be on the outside. When we do synthetic, you drop the 2. We multiply. 2 times negative 1 is negative 2, and then we add on the inside. So 5 minus 2 is 3. 3 times negative 1 is negative 3. Negative 7 minus 3 is negative 10. Positive 10 when I multiply. Positive 4 when I add. And then don't forget, when you're translating back into a math expression, you do have to drop a power because you technically divided out an x. So if I started at an x cubed, I now will be at an x squared. So I'll be at 2x squared plus 3x minus 10. And then to take care of my remainder, this guy right here, I'm going to put him over what I divided by, which was x plus 1. Now, as I said on this one, we're going to have to do long division. So I'm going to set up my long division bar here. I'm going to put 3x plus 2 on the outside and 3x cubed minus 4x squared plus 4x minus 2. And remember, the question we asked ourselves first is, what times 3x gives me 3x cubed? And you're probably saying, well, Marsh, that would be an x squared, right? So x squared times 3x would be 3x cubed. X squared times 2, because you got to distribute to both people on the outside, I would get 2x squared. don't forget to change the signs, okay? Because you're subtracting that value. So I get 3x cubed minus 3x cubed gone. I'm now at negative 6x squared. Don't forget to drop that 5x down. So now we ask, Now we ask ourselves again, something times 3x gives me negative 2x squared. That would be negative 2x, right? Negative 2x times 3x is negative 6x squared. Negative 2x times 2 is a negative 4x. Don't forget to change those signs. Let's drop the negative 2. And again, we keep going. So something times 3x gives me 9x. And you're saying, well, Marsh, that would be plus 3. So now let's multiply. 3 times 3x gives me 9x. 3 times 2 is 6. Change your signs. I got negative 8 for my remainder. Now, to do my remainder, I do have to, just like I did over here, I'm going to put plus, but you could put technically a minus here as well. Negative 8 over the guy I divided by, 3x plus 2. Okay. Next one here, that we need to determine all the real number solutions to the following polynomial. They did give us a 0, aka what you would use your calculator for to find an x-intercept. They gave us one as a hint. How nice are they? So we're going to take that 0 and put that on the outside of our synthetic division. I'm going to set up my synthetic division here. X, no x, so a 6, a negative 37, a 5, and a 6. So we're going to drop the 6 down. 6 times 6 is 36. Get a negative 1, negative 6, negative 1, negative 6, smiley face, right? Now let's go ahead and translate this back to math. Since I dropped a power, it'd be 6x squared minus 1x minus 1. Now we're finding all the solutions, which means we need to now factor this to get an answer. So I'm going to factor this problem here. 6x squared, let's try a 3x and a 2x, and then a 1 and a 1. So I have a 3x and a 2x. That can, in fact, make a negative 1x. So that'd be a negative 3, positive 2 to accomplish that task. So then if I solve, I'll get a negative 1/3 from this guy, a positive 1/2 from that guy, and don't forget the guy that started it all for your final answer, this guy right over here. Don't forget him. Very commonly we forget that he exists, and since this is a cube, you should only have 3 answers, so that 6 has to be there for that answer. And the final question, we're going to write the equation of the following polynomial that contains the following solutions. X equals negative 3, negative 1, 2, 5, and then we're going to contain the point 0, negative 15. So what I'm going to do is start writing what would I have solved to get those x answers. And don't forget, when you're writing the equation, you're solving for the a. You're looking for the stretch or the compressed value each time. So negative 3, I would have solved x plus 3 to get that value, right? Negative 1, I would have solved x plus 1, x minus 2 to get a 2, and then x minus 5 to get a positive 5. Finally, I need to solve for a. So I'm going to take my ordered pair, x comma y, and plug in my numbers. So y is negative 15, 0 plus 3, 0 plus 1, 0 minus 2, 0 minus 5. Okay, let's not be fancy here. I'm just going to go do some math. 0 plus 3 is 3, 0 plus 1 is 1, 0 minus 2 is negative 2, 0 minus 5 is negative 5. Okay, let's multiply all those things on the right together. 3 times 1 is 3, times a negative 2 is a negative 6, times a negative 5 is a positive 30. Dividing by 30, I will get a equals negative 1/2. Now, don't trip before you get to the finish line. Make sure this answer goes back into your equation for a final answer. So I'm going to get y equals negative 1/2 x plus 3, x plus 1, x minus 2, x minus 5. Whoop, running out of room. That last one, x minus 5. And that is the end of the polynomials review for semester 1. I hope you learned a little bit more and remembered the information about polynomial functions. And I will see you later, Sabers.